Okay. So we selected the one that we're graphing by the nature of the equation. We set it up to actual graph the equation the way we're comfortable, and then we're going to take that equation, we're going to put it on the polar graph, okay? So when I graph cosine, it starts up, then it goes to the center, and then it goes to its low point, back to the center, back up to the high point, to the max, and that's what my cosine looks like. And now I am going to convert these into points that we're going to use as polar coordinates. Now, when we were talking before, and we labeled the points at the beginning of class, we said at 0 pi, the value is 6, correct? These two things we need to flip-flop so that we can put it in a polar form. So what I'm going to do is I'm going to plot the point radius 6, angle 0 pi. So I'm going to do it the opposite way of what we normally would do to get it onto my graph. So my radius is 6, and I don't open my angle at all. I'll put a point on my polar graph at that spot. Radius 6, don't move any angle at all. My next point is pi over 2, 3. That means I have a radius of 3, and pi over 2 is my angle. Yes? Just because the polar coordinate has radius angle, it's r comma theta. And when we put it in this form as an x, y axis, it's not in, the angle isn't in the spot that we need it to graph as a form. Does that make any sense? Okay. And it's just how we labeled our stuff. This is like an x, y, and we want this to be our theta. Okay, so now I'm going to graph the point 3 pi over 2. That means I go out 3 and I go up to pi over 2. Is everybody okay with my move so far? Feeling okay? Okay. Then I'm going to go to my next one. That one is 0 pi. So that means I don't go out 0. And I go in the direction of pi, but I'm not going out anything, so it ends up being at the origin. So anytime my radius is 0, my point will end up being at the origin. And then I'll do my next point, 3 pi over 2, 3 pi over 2. And then my last point on my graph is 6, 2 pi. 6, 2 pi. Lands where I'm done. All right? So if I were just doing like a rectangular graphing or looking at this and I said like create this graph, or somebody off the street walked in here and looked at this, they might think, well, hey, wait, that just looks like it could be a T. It does look like it could be a T or a triangle, but it's not. Remember, we're creating a heart. And I'm going to show you what this looks like in graphing using a graphing calculator, and then we're going to put it together. Except for my mouse is over here now. I think I slid it over. I'm just going to minimize this. Nope, I didn't do it. I don't care. So we're going to do this process here ourselves as best we can. We are only human. But can you guys see that graph? Yeah. That's what our end result looks like. This is what we're going to have to create. So there's our first point. Then up here is 3 pi over 2. Then there's our 0. Okay? This is how it graphs. This is it in action. This is us creating this circular graph, if I can get my mouse where it needs to be. Come on, mouse, settle down. Here we go. It starts to curve around. This part gives us at this angle, at this angle. These are all the points in there that do that, okay? So it's this circular motion that creates the remainder of the graph. Now, you might be thinking, I don't know if I can do that. Again, it's going to create that rounded feel. Pi, or sine and cosine are circular graphs, circular functions. They move in curves. So we're going to do our best. I'm going to get my thing back up there, and I am going to create my graph. I know what it looks like because I had this. I know I had the points, but again, remember, I'm not sure which direction it's going. That I have to kind of do as I graph. So I start here, and I try to do my circular motion. It comes here, hits, backs out. We try our best to go through our graphs. I am never ever going to grade you on your prettiness of your graph. Just do your best to create what it's supposed to look like, okay? Go through the points that you have. All right? Okay. Let's try another one. What do I have here? It's the same thing. Except my A is 2 and my B is 4, and when I put A over B, I get a fraction 1/2. According to this, which one do I have? What's that? Nope. That one's greater than 2. This is a 1/2. What do I have? Inner loop. Yep, this one. Because my A over B is less than 1, it's a fraction. Good? So this is a inner loop. Okay? What this looks like is, again, it could be like here, 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 there. It could be on the other side, it could be on the bottom. I'm not going to draw both of those, but you get what I'm looking at. How do I know which one it is? Plot the points. Start from the beginning and do your curve. You'll start to see things happen. So let's get our graph going. I know what it's supposed to look like. Now I need to get some of my points. So this graph is a sine, nothing done to the angle, vertical shift of 2. So that's my new center. Tops out 4 above, bottoms out 4 below. So it's going to be at 6 is the high point, at -2 is the low point, and now I'm going to get all my other stuff labeled, and we'll sketch our graph. Yes?
Why is -2 the low point?
Because this will be 4 above the new center and 4 below the new center. So if my new center is 2, because it said raise it up 2, 4 above is 1, 2, 3, 4, so 3, 4, 5, 6. 4 below is 1, 2, 3, 4, or 1, 0, -1, -2.
So anything in front of like the sine or cosine will then multiply, except for like if it's the vertical shift thing?
I'm not sure what you're asking. Say it again. This
Oh, I
this is my amplitude.
Yeah, I figured that.
Are you sure?
Yeah.
Okay. Okay. So I'm going to graph my sine. Oops, I need to put this in. 2 pi, pi over 2, 3 pi over 2, and then I'll graph my sine. So it starts at 0, goes up, back to 0, low point, back to the 0 point, which is the center of the graph. It's not really 0. So there's my sine. And again, I'm going to pull out the points. And again, my first point is 0 pi 2. But that's an xy coordinate because this is my theta axis and this is my y-axis. But I want to treat it like I'm looking at a polar coordinate, which takes a radius and an angle. And so my real first point that I'm going to graph is 2, 0 pi. And so again, I can put that on my graph, 2, 0 pi. My next one is 6 pi over 2. So 6 pi over 2. Out 6, open it up, pi over 2. And then I have 2 pi. Out 2, over to pi. Out 2, open up pi. Uh-oh. -2, 3 pi over 2. Sheesh. How do I do that?
Just do it.
Yeah, I'm going to actually go left 3 and then 3 pi over 2 around, but actually it lands me at, or sorry, left 2, 3 pi over 2 around. So left 2, 3 pi over 2 around, that actually lands me up here. Good? Okay. All right. Now, there are 2 spots. Oops, I should finish this, sorry. My last point is 2 pi, and that's going to end where I started. Okay? And again, I have this graph, looking at it. Anybody coming in here would be like, I do not know what that is. But I do know that my graph does hit the axis here, right here and right here at 0, right? That's 0 on this graph. That means there's 2 points where this thing crosses the origin. So I have this point in here as well. And it's going to cross through that point twice, because twice my graph hits my original axis, and that has a radius of 0. Knowing that helps me. Knowing what it looks like helps me. So this one looks like it's going to go more in this general shape. I start here. I curve around to my next point that I went through. I keep curving around as much as I can. It's going to come down, and then it's going to cross through that point. Those zeros that I know are there because they're on the graph. It's going to keep curving. These are curves all the way through, and it'll end. These are just sketches, so again, I'm never going to look at your picture and go, oh, it's a terrible, terrible inner loop. I just want you to recognize what it is, take your points, and translate it as best you can. Yep. Yep. Mm-hmm. Because like I said earlier, when we were doing this one, if 0 is the radius, that means it doesn't go out at all. Okay? So it doesn't even matter what angle it's paired with, because it's not going out, so it's just staying at the center. It's basically like staying at the center and turning around, but still staying at the center, okay? This has 2 of them that have 0. Every single one of these points, there's a point where the radius is 1. There's a point where the radius is 2, where it's 3. Like all of these pieces have points on there, okay? And so this is the point where the radius is 0, and it's paired with something pi, I don't know. I don't really care. It's some pi that falls between 1 and 1.5 pi. Maybe it's 1 1/4, maybe it's 1 1/3. Again, it doesn't matter to me because the angle makes no difference. But I do know that this graph crosses through the origin because there is a 0 on this. And then it crosses back through again before it finishes up. Okay? So you're just going to look for things where it crosses our original axis because those are going to be origin points. All right? Yep.
For the point -2,
Yep.
3 pi over 2, how did I get to that?
Because remember, that means I move to the left 2, and then I have to open up 1.5 pi. Because that's what 3 pi over 2 is. So 1 pi, 1/2 pi. Good? Yeah. So I still am moving the same distance that an angle would be of that. I'm just not landing at where I think 3 pi over 2 is. Because it doesn't work like our x and y coordinates where they're really straightforward. Move left 2, up 4, and you're there. This is move out this far and open up this size angle from there. So they could be anywhere on the graph depending on whether you have a positive or a negative. Okay? All right, let's try another one. We all right? A little different. I'm going to give you that site or that thing on the computer, that link I'll put on Google Classroom, so that if you want to open it up and check to see what your graphs should look like to help you when you're graphing, you can absolutely use that, okay? So now let's take a look at this one. What do you think I have? I heard a rose. Anybody else agree with a rose? Got to be a rose. Why does it have to be a rose? Yeah, because it's got the little n in front of the angle. Okay. What does this 2 in front of the angle also change? The period of the graph, yeah. So it changes how we number our graph. It also means that it might take longer for us to get to 2 pi to finish this graph, to make one lap around and get our graph done. So we have to keep that in mind. So we decided this is a rose. And it's a cosine rose. Cosine rose. So cosine, where do we have cosine? It says something about n petals if n is odd, 2n petals if n is even. Yeah, so how many petals is this guy going to have? It's even, so I'm going to multiply it by 2. This is a rose with 4 petals. If that were a 3, it'd be a rose with 3 petals. If it were a 4, it'd be a rose with 8 petals. You get what I'm saying? Okay. Odd is true. Even is going to be double. All right? So I'm going to go ahead and graph this. I do not have a vertical shift in this graph. There's no 1 plus, 1 minus, anything like that. But what I do have is an adjusted period. So that's pi there. And this is pi over 2, and pi over 4, and 3 pi over 4. It tops out at 6. It bottoms out at -6. And I know what I want this to look like. I want it to be a shape that has 4 petals. Now they gave us a sine one, so my 4 petals might be shifted to cross the axes at different locations. It might, like rotate on here. So keep that in mind. But I'm going to go ahead and graph my cosine. Cosine starts up, down. There's my cosine graph. No fancy shifts. I like to have my cosine graph there so I can read it, so I can find my points. Remember that if I were interpreting this as rectangular coordinates, which is how we graphed it, my first point would be 0, pi, comma 6. But in polar, I want the radius first, 0, pi, and that's going to help me graph it. So I have to flip that coordinate and then open it up to the angle. So my first point is start at 6, and don't open. Then I have 0 pi over 4. What does that mean? It's right at the center. It's in the origin. Yep. It just stays at the center. Then I have another one that is -6 pi over 2. Okay, again, we've got that negative radius. How do I graph that? I go to the left 6 and move forward pi over 2. I meant to the left 6 and move forward pi over 2. So to the left 6 and move forward pi over 2. So that puts me here. And then I've got 0, 3 pi over 4. So that means this graph must go back to the origin. And then I have another point that is 6 and pi. So 6 and pi. Got another T-looking shape again. If I don't know what I'm looking at, yeah, it is, I'm up here with on the same thing on the other side. Yep, if I don't know what I'm looking at, I might not be able to figure out what this graph looks like, but because we're aware of what's going on, we can get this graph done. So, this piece is in a positive region, so for my first point, I'm going to be in the positive region on my graph in the first quadrant. That's my first start of my pedal. And then, the next point I graphed was here, and then it went like this, back to 0. And then I was in a positive region again, and I went over here. And then I look at this and I say, what the? That's not a 4-petaled rose. It's half the rose. We only graphed half of our distance here. So we've got to finish this off. That means I'm going to have values up to 2 pi. And you guys might be able to say, well, I know what's going to happen. It's just going to continue the rest and I can get whatever. And that's fine. If you can do that when you're graphing, go for it. But on your notes, I'm going to put all the points on so we can see it put together where it comes from. Yes? Yeah. So this was by pi over 4. So my next one here is 5 pi over 4. And then 6 pi over 4, which is 3 pi over 2. And then 7 pi over 4. And then 8 pi over 4, which is 2 pi. And then I'll just continue my graph all the way through, and I'll find those remaining points. So this is half of the rows. Now I want the other half. And that is from between pi and 2 pi. Okay, so we already got the 6 pi down there, so we're going to go to our next one. It's going to go back through the origin again. It is 0, 5 pi over 4, followed by -6, 3 pi over 2. Just reading my graph, followed by 0, 7 pi over 4, followed by 6, 2 pi. I'm going to plot these just in a different color. So I'm going to plot these in 0. I go back through the origin again, so where I stopped here is going to go back through the origin. Then I do my next one. -6, 3 pi over 2. Left 6, 1.5 pi. That puts me up here. So I'm going to continue my curve. Then I go back through the origin. And then I end where I started. And I have my rows. Again, you'll be able to use this sheet to help you find what it looks like. You'll be able to use the link on the graphing calculator that I entered in there. We're going to do one more and then I'm going to let you try. What's my last one? Another rose. But N petals if N is odd. So 3 petals. 2 N petals. So whatever the number is there is going to be my number of petals if it's odd. Twice that number is going to be my number of petals if it's even. So I've got 3 petals. Sign, no fancy shift. 2 pi over 3. Oops, that's 3. Sketch my sign. And start plotting my points. Again, this might not be enough of a graph to get my full thing done. I might have to continue with my points. Might have to extend my graph to find more. Or just continue with the pattern if you start to get a feel for it. So my first point is 0 radius at 0 pi. Radius of 3 at pi over 6. Radius of 0 at pi over 3. Radius of negative 3 at pi over 2. Radius of 0 at 2 pi over 3 again. So I'm going to see how far this gets on my 3-petaled rose that I'm making. My first point is at the center. And then I go 3 pi over 6. Then I go back to the center again. And then I go negative 3 pi over 2. And then I go back to the center again. And it sure as heck looks like I'm not going to be able to finish. So what I have so far is here to here. And I stopped. I can take a guess what's going to happen, but I'm going to also go ahead and finish this off. One more run through, see if that gets me to what I need. And so this is going to be counting by pi over 3s. My next one is pi, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. Continue my graph. Continue my points. So after 0, 2 pi over 3, I go up to 3 pi. That's this guy here. And then 0, 4 pi over 3. Moving along my graph. Negative 3, 5 pi over 3. And 0, 2 pi. Finish with my points. So 0, 2 pi over 3. Oops, did I not get there yet? I did 0 pi. that. I didn't finish this guy off. I didn't get to there. So my next one is 3 pi. 3 pi. And 0, 4 pi over 3. And then -3. Oh, I did my numbering wrong, you guys. Right from the bat here. I should have been counting by pi over 6. Well, it doesn't. It's not okay. This is ridiculous. 2 pi over, I should have known that something was off here. Okay, 2 pi over 3. My next one is pi over 6 more. So that is 4. So this should have been 5 pi over 6. This is pi, 6 pi over 6. This is 7 pi over 6. And this is 3 pi over 2. Sorry about that bad numbering. That's going to change these points. That's going to change the points on this graph. I hope you guys are using pencil, not pen like me. So this is 5 pi over 6 is what it should have been. 0 pi. -3, 7 pi over 6. And 0, 3 pi over 2. What made me think that something is wrong here is when I started to graph this. It's going to be symmetrical. And so things are going to be all a little bit kind of evenly spaced between them. And I could tell that it wasn't going to be like that when I graphed it. So my next actual point, stopping here, good thing I didn't draw anymore. My next actual point is 5 pi over 6, so that guy should have been right here. That looks better, that evens it out, so it's where the pink thing is. Again, I apologize for that. I numbered wrong. Be careful how you number. Always go off your first value here. That's what you're going to add on as you go. So this should be like that. That finishes. We actually end right here. It stops us. It brings us back 0 pi. The other stuff is just going to start to repeat. So what will happen is if I graph -3, 7 pi over 6, that's -3 and then 7 pi over 6 would put me 3 quadrants in, and I start repeating this again. Okay? Yes. Okay. So I'm going to let you guys keep these tonight. All right? Put them in a safe place. If you think you can't be trusted, give it to me before you leave, but I will collect them from you tomorrow, or Monday, I mean. Okay? And I'm also going to give you the link on the computer for that program, or for that graphing calculator. But you're not going to work out of your homework packet tonight. What? I should have warned you of that initially. I apologize. No. We didn't do circles only because circles are probably the easiest ones. A circle is pretty obvious when you do a circle, right? So it's not good. This is what we're doing today. And in fact, on this, my directions are.
Really?
You have, yeah.
So we don't have to do anything, right?
No, nothing in the homework packet. Okay, so these are my directions for you today. There are 6 graphs on here. 7 graphs on here. Okay? What I want you to do is I want you to find one limacon, 1 rose, and 1 circle. And graph them. Find and graph. So of the 7 graphs, you're not all maybe going to do the same 7. but I want you to find 7 or just 3 graphs to do. 1 limacon, 1 rose, 1 circle. So look at it, pick out the one, pick what it is. If you decide that's what you want it to be, label it as that, graph it. And then, let's say you thought it was a limacon, it ended up being a rose, then obviously look for another limacon, not another rose, right? Okay. But I think you should be able to pretty much tell what's what pretty easily by the nature of the equation.